Hello, Math 6. We are in day 3 of our functions unit. Our lesson today is functions, tables, and graphs. Make sure you're ready to pause the tape when you need to do some writing, and then you can always, well, not the tape, the video, but you can always rewind if I go too fast or you need to hear something over again. Go ahead and turn now to page 10 for our notes. So our lesson today starts with a warm-up, which is a review from yesterday's lesson, interpreting graphs. So let's read it. Maxine biked 6 miles from her house to the park. She played some softball, then she biked 4 miles further to the movie theater. After watching a movie, Maxine returned home. Complete the graph so that it shows the distance Maxine is from home compared to time. What I want you to notice in this graph is what our labels are. On our x-axis, we have the label time. So that's going to be showing time as time goes by. Our y variable is distance from Maxine's house. So as she gets further from home, we're going to see that line go up. As she gets closer back to home, that line should come down. So let's think about the information we were given in our description. So we've got Maxine biked 6 miles from her house to the park, and at the park she played some softball. So she's going to spend some time there. So in my graph, she's going to go from home and she is biking. So if she's biking, she's not going to get there instantly. So we're not going to see a curve like that. It's going to happen over time. She bikes. Biking's pretty fast, so I'm showing a pretty steep graph. When she was at the park, she played some softball. So I'm going to assume she was there for a while. She's playing softball. Then in our graph it says then she biked 4 miles further to the movie theater. So that part of the graph is going to show her going from 6 miles where the park is further is going to take her to 10 miles from home. There she watches a movie. So if she's watching a movie, we're going to see that graph flatten out while she watches the movie. After that, it says she returned home. Well, we know she's biking home. That's how she got to the movie. She's got that 10 miles. If she's biking home, we're going to see her getting closer and closer to home. So the graph should have a shape something like that. Let's move on to vocabulary. Our terms today are input, output, and function. Starting with input, input is the value that is substituted into the function. So we're going to write the word function here. Remember, our function is our rule. So the value substituted into the function or expression, it's in our function, it is our x value. So write that in there too. It's our x value. Output is the value that results from substitution of our given input into the function. So again, we're going to write function. So today we're going to be working with function tables. Our x value is also called our input. Our output is our y value. And then finally, function. An input-output relationship that has exactly one output for every input. In elementary school, you called function tables in and out tables. So if you remember in and out tables, that was your introduction to a function table. So now we're going to try our first function table. So we're down at the bottom of page 10. Example 1. The first thing I want you to notice is this chart here. This chart has the integer rules, which we're going to need today, just as a reminder. So the way to read this, if I have a positive number times a positive number, I get a positive product. For example, if I have 4 times 5, those are both positive numbers. That's just going to give me a positive 20. The next line says a negative times a negative is also a positive. So that would look like negative 4 times negative 5 is going to equal a positive 20. So two negatives multiplied together make a positive. Two positives multiplied together also make a positive. If the signs are mixed up, a positive times a negative, or as you see on the bottom, a negative times a positive, we get a negative result. So that with our 4 and 5 would look like positive 4 times a negative 5. That's 4 groups of a negative 5, and that's going to be negative 20. And then a negative times a positive is also negative. So if I have negative 4 and I have 5 groups of that, that's going to also be that negative 20. So if the signs are opposite, positive and a negative, your answer is negative. If the signs are the same, it's going to be positive. So same signs, positive, different signs, negative. I'm going to erase that so it's not kind of bumping into my function table. You might want to keep it there though if it's helpful for you. All right. Okay, so now let's move on to our input-output table. So we see our function here that we're going to try is y equals 8x plus 5. Y equals 8x plus 5 is our rule, and you see our rule is written in the middle. On the left side, we have input. So these are, if you remember from our vocab, this is our x value. -4, -2, and then a 1. Our output value is going to be what comes out when I put that x into our rule. So our output is going to be our y value, and we're going to be writing those there. So to get started, we're going to take our x value, which the first x value is -4, and we're going to substitute that -4 in the rule where the x was. Right there, -4. And then we're going to simplify, which means do the math. So we have 8 times -4. So if we use our chart over here, those are different signs. A +8 and a -4 is going to be negative, and 8 times 4 is 32. So -32 plus a +5. Well, think about it this way. If it's -32 degrees out, which it seems like it was not too long ago, and we add 5 degrees, it gets 5 degrees warmer. Now we're at -27 degrees, -27. Now let's go to the next one. Next one says -2 is our input. So we're going to substitute a -2 for x and then simplify. So we have 8 times -2, and again we have different signs, a positive and a negative. So our solution there will be a -16 with a +5. So if it's -16 and it gets 5 degrees warmer, it's still cold, but it's up to -11. For the last one, our x value is a +1. So we put +1 in the table. 8 times +1, well, 8 times 1, those are both positive, that's 8, plus 5 more gives us 13, positive 13. Oops, I had forgotten to put the 1 down below, so make sure you do that as well. So your table should look like this. Let's go on to page 11. All right, so here's our second example. So it looks longer, same idea though. We're going to put our input values into the rule, and then we're going to simplify that expression to find our output values. This time then, we're going to take our results, our x and our y values, and graph the ordered pairs. So I want you to pause and fill in just your input values. So take, for example, I'll do the first one, take that first x and put it into the rule, -2. So go ahead and finish filling in all of your x values. Then press play. All right, now you should have your x values all filled in, and we're going to simplify the expressions to discover what our y values are, our output. So the first problem says positive 3 times -2 minus 4. So 3 times -2, we have different signs, so that's going to be a -6 minus 4. So I'm going to keep using that temperature analogy. So if it's -6 and we subtract 4, we're going to end up at a very chilly -10. Three times -1. 3 times -1, well, different signs, so that's a -3. Minus 4 takes us to -7. I'd like you to pause again and fill in the rest of your output values. Let's see how you do. All right, so hopefully you got those all filled in. If you made some mistakes with those negatives, don't get too stressed out about that. We just want to expose you to this. So do your best, but it's not going to be tested with negatives yet, just a little bit of exposure. So now I'm going to create ordered pairs, and we can see here the ordered pair is made from our x value and then our y value. So our x values, well, those are the first numbers we were given, and I'm just writing in my commas. So an ordered pair is always going to need a comma in the middle and parentheses around the outside. So I'm going to put in my commas. So here's my empty ordered pairs. My x values are just what I have over in the x column. So what I started with over here. These are going to become my x values for my ordered pair. So I'm going to start with -2 for x, and second I had -1. Go ahead and fill in the rest. And now you should have those filled in, and we're going to fill in our y values, and our y values are what came out of our function. So they're what I have written in blue, and we're going to put those right in the y spot. So -2, -10 is our first ordered pair. So take your y values, write them in this column, creating our ordered pairs. The next thing we're going to do is graph our ordered pairs. I'm going to use green to graph. You can use whatever you want. So I'm going to start here with -2, -10. The first number is my x value, so that's going to be where my point is on the x-axis. Then my y value is going to help me graph on my y-axis. So -2, -10 is going to go -2 from the origin, so over to there, and then I'm going to go down to -10. So I'm going to put a point right there. I'm going to erase my little scribbles. Okay. And then I have -1, -7. It's going to go right here. And I'm going to pause and go ahead and graph the rest of those points. So hopefully when you've graphed your points, you'll end up with this. And I hope you're noticing that these points, if I were to try to connect them with a line, I have a straight line there. This is a linear function. Let's try our last example. All right, here's our last example. Check it out. Find the output for the input. And our function is y equals 3x squared. So if I think about order of operations, I know we're going to need to square our x value, our input value, and then multiply that by 3. So I'm going to do the first line with you, then I want you to pause and do the rest on your own. This first one will help us practice the exponents. So 3x squared, if x is -2, and I have -2 squared means -2 times -2. So that's over here. A negative times a negative is a positive. So -2 times -2 is +4. And +4 times 3 is 12. So our output value is 12. If you're kind of having trouble with these positive, negative things, it's okay to use your calculator. Make sure you're using a scientific calculator that has negatives, and that'll help you and make sure you're not going to make any mistakes with the negatives. Okay, pause your video and go ahead and try filling in the rest of the example. So here are the rest of the outputs for this function. When we put in a 0, 0 squared is 0, times 3 is still 0. 5 squared is 25, and 3 25s is 75. All right, time to get on to the homework. So the homework today is just page 12. You'll see I have that little chart up at the top, so you can use it as a reference. Again, if you're having trouble with the positive and negative things, check with your calculator to make sure that you're doing it correctly. You're going to have two tables where you're just practicing doing the input output, and then you have two examples that you're going to graph. I'm going to enlarge this a little bit. When you are inputting the rule, think about what it looked like in our notes. So I want you to write 5, put parentheses where you're going to input your x value, your input value. So here, when I put that -2 in, it's going to go in this spot. -2 times a +5. Signs are different. So that's a -10. 5 times -2, -10. -1, it gets 1 degree colder. Well, that's going to be -11. Let's try the next one. Same rule, 5 times our input, we're just going to put parentheses there, -1. And our input is 0. Well, 5 zeros, 5 times 0 is 0. 0 minus 1 is 1 below 0, -1. Now, on your iPad, you can go ahead in Notability and copy and paste this function. So this part, you can copy and paste for your function tables, so you don't have to write it each time. On this video program, I have to write it each time. So 5 times my input is 3. 5 times 3 is 15. 15 minus 1 is 14. And my last input is 6. So I'm going to put the 6 in the parentheses. 5 times 6 is 30. 30 minus 1 is 29. So there is your first function table done. You're going to complete the second function table. And again, the third and fourth, you're going to graph those ordered pairs as well. I hope this is making sense for you. If not, ask your teacher for some extra help or check your textbook, lesson 5-3, for some extra tips. Bye-bye.